All right, class. Let's gather around. Get in our seats. So first, how is everybody doing today? Who wants to share out what they do over the weekend? Okay, Calicia. Okay. Went to Coney Island in this cold weather? That don't make no sense. I don't know why you do that. Anyway, we're gonna get into the lesson, all right? So, remember how last time we talked about solids, liquids, and gases, and we were trying to categorize them, put them into different columns based on if they're solid, liquid, or gas. Let's just review that. What's a solid? Isaac. Okay, a solid is something that always has the same shape, always takes up the same space. Okay. What about liquids? Come on, anybody. Zakia. Okay. So you're saying liquids, they always stay the same shape? I know they take up the same space. Do they always stay the same shape? Who wants to help Zakia out? Samaya? Okay. I'm hearing a little bit more better from Samaya. Samaya said that liquids only take the shape of their containers. Do we all agree? I think that's what we learned last time, right? Let's keep going. What about gases? Do gases have shapes? I'm hearing a lot of no's. What about do they take up space? Do they take up space? They do take up space. Might have to review that a little bit. But anyway, so now that we know a little bit about liquids, solids, and gases, we learned about that last semester. We know their properties, and we know we don't know how they're formed, but we do know their properties, right? So now we're gonna go a little more in depth with that, right? So, learning objective. I can analyze the transformations of matter and separate them based on their chemical reactions. Anybody know what a chemical reaction is? Seeing a lot of question marks. Okay, so chemical reaction is something that happens to the matter when it comes into contact with heat or cold, and it changes, right? For example, can anybody tell me what happens when you put water in the freezer? Anybody ever done that before? It's a hot summer day, or you're gonna be on the beach tomorrow, so you gotta put some waters in the freezer. And what happens with that water? Osa Raymond? Right? It turns to ice. Does it turn to ice instantaneously? Like, does it turn to ice right away? No, it doesn't, right? It takes time. It's like overnight, right? That process of it turning to ice is called freezing. So here, I have a couple of ice cubes, right? That I left overnight. I had a little ice cube tray. I put them in my freezer just for this lesson, right? And I brought them in to show you guys that this is water that was frozen, went through freezing, and it became a solid. So that right there is a transformation. The chemical reaction was that the liquid is going from water to ice, liquid to solid. The transformation is freezing, right? We see that's what that is, right? Now let's explore a little bit more. What happens when ice gets warm? The opposite. Let's start from ice. You have ice, right? You have a nice ice cold bottle of water. It's almost frozen. You can't drink from it, and you leave it in the sun. What's gonna happen to it? It's gonna melt, right? It's gonna melt. You think melting is a transformation? Awesome. So, melting is a transformation, and it does happen to solids mainly, when ice, let's say ice for now, is exposed to heat or extreme heat, and then it starts to melt. Its molecules start to break apart, slip past each other. Remember how we learned about how molecules and liquids are always moving past each other? It starts to do that until it becomes a full liquid, right? As you can see, the ice already, I don't know if you can see it, I might have to bring it a little closer. The ice already is turning to liquid because it's hot in here, right? So of course, over time, this ice in this bag is gonna turn all into water, right? So let's move on to our vocabulary, right? So we already described melting, we already described freezing, right? Most people know about those ones. We can go over them, we will. But let's talk about something a little more unique. Let's talk about vaporization. Can anybody say that with me? Vaporization, right? So, vaporization. When a liquid is exposed to extreme heat and its molecules break away, forming a gas. Similar to how solids become liquids. But the heat has to be... Anybody ever heard of boiling? Yes, you boil water to make tea. Yes, you boil water to put on your back when it hurts and stuff in the water bag. Yeah, right? So, when water is boiled, or liquid is boiled, it turns into a gas. So, I have another example here. I boiled some water before class and I brought it in. I had to make sure this didn't get cold in the weather. So what I'm going to do is I'm going to pour this water in this cup. And you're going to see that the water vapor that was sitting in here is going to start coming off the top of the cup. It's almost going to look like smoke, right? So you guys ready? Watch this. Let's see if you can tell me if you can see the water vapor. I'm seeing it. I'm going to keep pouring. So we get a lot in there, right? Can you see? Anybody can see that water vapor? Probably can barely see it from how far you guys are, but it's there, right? And that's water vapor. Now, water vapor happens because the water was boiled. Maybe I was going to make some tea with this. Maybe I was going to use it for something else. But the water is boiled. When the water is boiled, its molecules start moving very, very fast. And they start breaking away from each other. And that's how it turns into a gas. And that's why it just goes everywhere, right? I don't know where to set this down. Let's just put this on the floor for now. So, that is vaporization. Last two vocabulary words we're going to talk about is permanent and reversible. Does anybody know what it means when something is permanent? I permanently am going to wear glasses. I'm permanently a teacher for the next year, right? What does it mean to be permanent? Let's see my hymen. Maybe. You're saying that it's when something's always stays the same? Yeah, I think so. It always stays the same. When something is permanent, it's never gonna change, right? So, what about reversible? What do you think reversible means? Well, let's use our context clues. What does the word reversible have in it? Let's break down that word. Reverse, right? And what does it mean to reverse? To go back, okay, to go back, to change back, right? So reversible means when you can change something back to what it was before. What's an example of something you could change back to what it was before? Just give me anything. Toy, food, I don't know, what else? Let's see. Think. Come on, you guys got wait time. Ivana? You're saying clothes? Yeah, clothes. You can change out of clothes, change back into clothes. That works. It's reversible. Well, the process of putting on the clothes is reversible, but yes, it is reversible, right? So, with that being said, we're going to explore today what transformations are permanent and what transformations are reversible, right? So we're going to see if water is going through vaporization, is turning into gas. You think that's reversible? You think it can go back into liquid? I'm seeing a lot of mixed signals here. Well, we're going to find out. We're going to explore more, right? And then we're going to explore which ones are permanent as well. If it always stays the same no matter what, it cannot go back. So we're going to get into that later. But right now, let's see if we can go into our groups because we're going to do a little bit more experimenting. Okay. This off.